Hey guys, and I was just going to show you a little bit of incoming that I got. Tom, you probably saw in some of his videos, he was going to, or in one of his videos, he was going to send me a little 1-2-3 block that he picked up at a yard sale. It actually looks incomplete. There's this little guy here, and it seems like it's been ground on 3 sides. It's been ground on one of the 2 1-inch sides. It's been ground on one of the 2 2-inch sides, and it's been ground on one of the 2 3-inch sides. It's what looks like mill marks there, and I haven't measured it yet, but Tom did, and he said it was about 12 thou over in all directions, and the surface grind on there doesn't look great. I think I'm going to start probably with the guy's original reference points, which means he had the machine surfaces down against the mag, and it's old and kind of rusty. I'm gonna give it a quick lap and just make sure that we got no high spots or any dings from mishandling, and kind of see where we're at with it. And I think I'm gonna start off with the big surface here on top and machine side down, and we'll just give it a measure. And then check it on the 3 sides, machine side down in all directions, and just kind of see where we're at with it, and kind of come up with a plan of attack of how we're going to grind it parallel, square, and to size. This is a good project. I've never made a 1-2-3 block. I am going to, I just took it out of the box, so I'm not sure what the material is. It's steel of some sort. I don't know if it's hardened. I'm going to take it over and strike it with a file and see how hard it is. Hopefully it's hardened. And it's kind of tricky because we're kind of rusty here on a lot of these surfaces, and the first few passes with the wheel are going to load them up kind of badly. So the first few cuts are going to be just all cleanup. I've only got 12 thousandths to work with, so you know, we've probably got 1 or 2 thousandths just that are going to pollute the wheel, and we'll have to redress, start over, retouch off, blah blah blah. And so it's there's not a whole lot there to work with, and I'm going to be very careful not to make it undersized. I mean, you can get stuff parallel, and you can get stuff square, and you can get stuff to size, but bringing all 3 together at the same time is challenging, and I'm going to do my best on it. This is actually a good project and a good learning experience for me. And then we'll send it back to Tom to, I think the name of his company that I called him was Anal Measuring Surfaces R Us or something. I don't know. Anyways, I change his mailing address or his mailing label every time I send something to him. The last one he sent to me was called Bar Z Industrial Shenanigans. So yeah, we're having fun with that. So got a 1-2-3 block project to play with. So stay tuned for the beginnings of that. I'm gonna shoot some vid over on the surface plate, and we'll get some preliminary stuff, some lapping and some preliminary measuring, and get a plan of attack for that. All right, so that's that. Right here. He sent me a repair tag for his for the angle squares. He sent 2 sets back to me. He sent a set of 60/30s back, and if I remember right, those measured 3 or 4 tenths off. And usually when they get that close, I just hand lap them, which is probably what I'm going to do. I haven't measured them yet to see where we're at, but I might have to go back to that video and see which direction they were off. He didn't send his standards. I've got my blocks, and which are, like I said, just shop grade. They're not good, you know, lab grade blocks that I measure my stuff with. So there's definitely room for improvement on my measuring station. But I'm going to measure them and go back to his video and study it very closely on which way he measured them and which way they were out, and see if I get the same result. So I may shoot a little video on that. So that was one. It says in need of repair. Z-squares, also known as stangles. Angle error detected. You know, I don't care what unit of measurement you're going to measure something. There's always a finer unit of measurement that you can go beyond. The second thing on the repair tag, height incorrect for curt use. General suction. And it's signed Mr. Wizard. Okay. I was having a conversation with a machinist one day, and I forgot what I was measuring. I was setting up his machine for him, and we had just got it wired, and I was working on getting the table level and getting him all, you know, bolted down to the floor. We were doing some grouting around the machine to help stabilize it, and I used the word perfect. I go, oh man, that's perfect. And he goes, there's no such thing as perfect. He says, I don't care how close you can measure something, there's always another unit of measurement that's more finite that will measure it even closer, and nothing can ever be perfect. And we had this long banter about perfect and not perfect. I walked out to the parking lot. See, there's nothing around here to show you, but I walked out to the parking lot and I picked up a rock. And I brought back in a rock and I handed it to him. He said, what the heck is that? I said, that rock is perfect. Just because it is. Okay, so enough of finite measurement. Here, let's get over on the surface plate and I'll show you where the squares are at and what we're going to do with them. So with my brand new AUX approved surface gauge, I'm going to fix Tom's squares. What I'm going to do, I'm going to measure off of this fence right here, and right off the surface plate, and I'm going to create a bias right here. I'm just going to run this down right now, and I don't know whether you're in close enough, but we're on 0 right there. But then I'm going to raise it up just high enough, just barely rest it on that fence. I think you can see what I'm doing there. Alright, and now with it, I'm going to go ahead and just lock that. Now I'm going to change my scale. I'm going to pull it up and get it adjusted in at 0. So this is just like doing your dial calipers and creating a bias in your dial calipers or whatever. And let's go up to here. And my read is, okay, I'm 0 there. And I'm line to line there, and I'm line to line there. So I'm happy there. So I'm going to go ahead and lock that scale way up here at the top. I'm going to unlock here. And I believe Tom's number was 1.7. So I'm going to go ahead and run this up 1.7. I think his reading was 1.7. Oh gosh, I should probably go look it up. Make sure I get them right this time. Let's just call it 1.7 on the dot for now. And we'll see how much we're missing out of these things. And make sure I'm still in frame. Get my big meat hooks out of the way. And yeah, we're just, gosh, he is just barely clipping those things. You can see right there. So let's actually measure it and see what we are. And remember, we've got a bias plugged in there, so we're going off of the top of that fence. I'm just going to bring it down gently right here, just till I can feel it starting to drag on that little guy there. There it is. I can just feel it. I'm going to lock and have a good look at that. Now, I got to turn this away from the camera so I can, otherwise you're going to be looking at the back of my head, and that you don't want to see that. So let's see what we got here. 1.7, 5. Let's start going up the scale. 7.5, 7.6, 7.65. Yeah, About 1.765. So we need to take a little bit off of there. I'm gonna go look up that video of Tom's and see what actually he measured. I know he took a measurement and stuck it online, but I did not write it down. So I'm going to put these in a grinding fixture that I have. These two squares. Let me get this in frame. Get this guy out of the way. These two guys here, and it's essentially just a flat plate that I slip in between them. And then I've got a fixture that actually clamps them together, and I can drop them down side by side, either this way or this way. But it's the same material thickness as this. I believe that was an 1/8 inch piece of plate that I surface ground on both sides, just as kind of a clamping fixture. They're going over the surface grinder. It'll take just a few minutes, and then while they're freshly ground right on the tips, I'm just going to dip them in gun blue. I'm going to go straight from the grinder, give them a quick blast with water, and I'm going to stick them in the gun blue, and just all it's going to do is just gun blue the very tip where it's going to get shiny. But then these are ready to go back. These will fit his Kurt Weiss after I've determined the height of his vise. But I need to go inside and check a YouTube video to get his dimensions. I know it was 1.7 something. So no more guesswork. All right, thanks for watching. Okay, and over here on the surface plate, we've got Tom's squares ground. And I'm going to try to show you what we did to them. Let me get a little closer here. This corner here, and this corner over here, were put, they're 90 degrees from the base, and they're sitting this direction. I didn't really like the way they looked. If you just go straight in like this, make a cut like that, it just gave them kind of an overall funny look. So they're vertically cut here and here, and then a horizontal grind there. So those are the reliefs that got put in them. This relief was already in there. These are the ones I added, and this is where we're taking them. We're going to the bottom edge and creating a bias on the surface gauge. Then we go up to the top and check it up here. And I took all of Tom's numbers, and actually I just erased them off the board, but I got them within, he should have about 20 thousandths clear, so he's got room to grind his jaws if the need arises. And then they got, I cleaned them with a high pH cleaner and put the whole thing in gun blue. So this is I didn't actually touch up the gun blue. I did a full gun blue on them. So if you look at the previous videos, you'll see the color variation of those. Trying to catch the light there, but this is a full black, so they're actually going to match his other squares. I didn't repolish them. All I did was clean them in LPS. The brand name is LPS, and the solvent is SAX. It's a water-based, high pH solvent, waterborne solvent, and then just hot water, and scrubbed them down real good with, you know, a stiff camel brush, and then just put them straight to the gun blue. And there's the edges that got ground, and the coloring that got on those, and the overall match is really good on the gun blue. Okay, but let's measure them. That's what we're here for. So let's see where we're at. I still have my bias plugged in there, so we're going to sit here. Oh, let me get my hands out of the way so you can see. There you go. All right, so we're still right on the fence, and line to line, line to line. So we're zeroed. And let's get down right to there, and just bring them in so I can feel it touch. There we have it. Let's tip that up so I can get a good look at it. And once again, no glasses. 1.7, 1.75, 6, 7, 8, about 1.78 is what these come in at. It's fenced down, and they're right there with each other. So these are ground in a pair, and you know, I went ahead and ground both sides. I went off just the fence side, and I ground just the side that creates the issue. But then the overall looks and the overall aesthetics of the thing was kind of silly looking with one side ground and one side not. So I just matched the other side. So these are done as far as his clearance issues, which is technically the easy part because he sent these back for general suckage. So he's gonna have to. I'm gonna check these for 45. He didn't state whether these were out, so I'm gonna measure these for 90 and then again for 45 and see how we are with them. And I guess I'll send him back for my semester final. Okay, that's that. Okay, I hope you enjoyed that little bit. That was fun. And over in our job site, we're coming up on the home stretch on that conveyor line. The rail's all hung up. It's got an elevated drive. The elevated drive's hung. And we're just now prepping the track and getting the track cleaned out and all the welds cleaned inside the track, which is no fun. Using a die grinder through a conveyor slot overhead, trimming welds and making sure that the chain's not going to catch on any of the welds inside of the conveyor track with metal chips flying down in your face. Does that sound fun to you? It's not fun. But anyway, we're prepping the track, getting it cleaned up, doing all the touch up on it, and we're going to load chain into it. That system takes 380 foot of chain. So we're going to be loading chain into it first of next week, get the drive wired and start running the chain. And it's got about a 10-hour break-in period where we run the chain under heavy oil conditions to get the chain loaded and get the chain to stretch and tensioning the take-up and getting that thing to run right where it'll be stable when the customer starts to use it, so he doesn't get a bunch of chain stretch right out of the gate, and we get a bunch of wadded up chain at the drive. So we are going to run it for about 10 hours before we pass it off to the customer. So here, let's go to that, and we'll take a look at our progress over there in that job. Morning, everybody. And here's some of our progress on the conveyor. Got the drive installed. Take up there in the back. That's what takes the slack out of the chain. Twin track. And there's a drop-off point there. And then it comes over here. There's a pickup point there. That little switch over there is known as a frog switch. That's what switches you back and forth. And we've been playing with the carriers and trying to determine the customer's requirements. Up there on the carrier, let's see if we can get up there in that little black tube. There's a cam over mechanism. What happens is we can turn the door 90 degrees, and if we let go, she's always going to snap back to knife edge, no matter which way you put it. So it can only index two different ways, and the only two ways are cam it over the other way. And there she snaps back to parallel with the conveyor. And up on top, you can see the dogs. The dog is on the left, and that's what rides on the actual drive chain. And the carrier is on the right, and that's what carries the actual part. So the dog chain is in constant motion. The drive chain is always moving. And the pickup drop-off points are where the drive chain pull away from the product line. But stay tuned for that little black rotator. I'm probably going to shoot a little video of the cams and everything that go inside of that tube. It's just a piece of 1-inch DOM 125 wall tubing. All right, but the rest, track's complete. Just needs to be prepped and cleaned, ready to accept the chain. Our control panel is in, and power's been applied to it. We see you go turn a breaker on, and then those run up through the roof of the building to grab all the rooftop blowers and everything. And we still got some more pipes to put in on that rack to get out to the conveyor drive and some of the emergency stops around this place. But the tracking is going to be complete today. There's very little left to do. And then it's just track prep and some touch-up paint and start loading some chain. And there's your oven. And twin track running through the oven there. And there's another frog to get stuff off the line. That frog switches back and forth. There's a manual section where they can pull them off by hand. All right, that's progress. Okay, and over at the job site, I briefly talked about the rotators on the conveyor, and you saw the black tubes up there. I'm going to try to draw that. It's kind of a crazy little cam setup inside that black tube, and you know, we're just prototyping now. After we're done with it, I'm probably going to have to make 45 or 50 of them for each hook on the line. And the bottom piece, how should I draw it? The bottom piece, top view, it's going to have a 1/2-inch threaded hole, but then it's going to have V-notches cut in it like that. It's like a lifesaver. Side view. Side view looks like this. And threaded hole here down the center. Now this V-notch goes 2 different ways, so the part can index in parallel with the conveyor or adjacent to the conveyor. So it'll do either one. And then out of this threaded hole, there's a threaded stud. Oh, this is terrible drawing. So we've got a threaded stud coming off of there. And then in the top piece, we're not going to do a 4-sided V-notch. In the top piece we have just a 2-sided V-notch, and this inside of here is actually a clearance hole. So we're threaded here, we're clearanced here, and this threaded stud goes up to the conveyor. Let me draw some contrasting colors here. let's do the threaded stud in blue. Make it a little taller here. All right. So your threaded stud is there, and we've got a threaded connection here, and we've got a slip connection there, clearance. And then let's do some more in black. Over this other one, the sleeve comes off this top, the sleeve's down, and then right below here, all we've got is a threaded drop-in down here. And that's for attachment down to the conveyor. And within, right on the side, there's a greaser. Ooh, let's see how we do greaser. Ooh, look at that. All right. So we got a greaser on the side, so they can lift that up, give it a shot of grease, and pull the cam back down, and it'll provide grease inside of that cam. Now this is a 4-way index, so this lower piece has the V groove going 2 different directions, 90 degrees apart. There's a 2-way and a 4-way. Right now we've got the prototype is a 2-way, but the customer is considering a 4-way. When we put that in, the parts they'll be able to index flat and come down the conveyor line like this. Now the problem with that, you saw the door is coming straight at you, but now we've got a 4-foot wide door coming at a 1-foot wide conveyor opening in an oven or a spray booth. And they absolutely have to get back to knife edge to get through the opening. And that's going to come in with the rotators. We're putting auto rotators on them so that if they do get flipped adjacent to the line, they can get flipped back parallel with the line. So these are the parts we have to make. We're still getting customer approval. I'm making a 4-way this weekend, and he's going to try the 2-ways and the 4-ways, and then we're going to talk about rotating options after we get back out on the job. And conveyor companies don't do work handling or logistics like I'm building into this system, or logic. I guess you could call it conveyor logic. And that's what I do. I'm the one I get a bill of goods, and then I have to get it installed, and then work closely with the customer, determine his requirements, and then make the system work for him as far as it can go, and get it as automatic as I can get it. But so that's what's going on out at that job, and I'm working with the customer on his work holding and his indexing, and how the parts stack up and how the parts knife edge and things like that. So there's that, and that's kind of fun. All right. Here's a quick angle update. These are a set of 3-inch you guys use for the mini pellets. And I don't have a good pair of 3-inch. I'm gonna move that one over. Back in the stands pile. The rest of those are available to you guys. Actually, 2 pairs are spoken for. The others are okay for you guys. So I still got to cut out the webs. The webs have been marked. But everything's been thinned and done, and I haven't had a whole lot of time to work on them. I'll probably get to some this weekend. Okay, that's it for the squares. Okay, and during the week we did some of the chip control videos with some of the guys around on YouTube, which has been kind of fun. We've been having some fun with some high-speed steel tooling, and I probably got the lowest horsepower in class here. I'm still running a 1 horse on my machine. I've got a 2 horse slated to put on it, but horsepower isn't my big strong point on that machine, and neither is mass. That's not a heavy machine. It's just a little Logan 2555, and to make use of my available horsepower, I've found that decreasing the load on the lead screw plays a big part of it. And let me explain what I'm talking about. Say you've got a part here, and maybe this is your cut line, and we're spindled out here, and now our cutting tool is here, okay, and we're obviously feeding in this direction. And with, you know, when with these, and it's all about the this back angle or top angle, whatever you want to call it. Anyways, this back angle here. What problems I've had and the solutions I've come up with to make my available horsepower focus on the cut. Remember, you're driving a lead screw very hard too. So this back angle here, I'm not talking about included angle, just this back angle right here. If I take it from, I've found that if I take it from 8 to 10 to 12, basically the tool gets to a point where it gets on the ragged edge of self-feeding, where it's actually pulling the tool into the work. And when you do that, when you find that sweet spot where the tool's actually pulling into the work, you're decreasing the load on the lead screw, and you're making your horsepower available to the cut. And there's a fine line between that. You don't want to pull the backlash out of the lead screw and actually pull the tool in, but you do want to get it to a point where it self-feeds and takes some of the load off of the lead screw. You still want the lead screw to be leading, not trailing, but you still want it to lead. But this rearward angle has an awful lot to do with the way the machine feeds and making the most of your available horsepower. Anyways, so that's that. And I'm pretty much done. I went all in, I made my cut, and I saw the load down on my carriage, and you know, there was a lot of downforce on that carriage, and it's not a heavy lathe, and I think my limiting factor is going to be mass of the machine, and I certainly don't want to break my machine. So I'm done, and I'm going to hold with my 0.900 at 1 horsepower. All right, so that's all Stan's going to do, and hope you guys have a good weekend. This should air maybe Saturday night, and we'll go from there. All right, we'll have a good week next week. Enjoy your Sunday. For those of you that were concerned, thank you for your emails about the fires here in Cucamonga. We did have some fires that were very close, but I was not on the mandatory evacuation list. The fires did come through the hills behind my house. And thanks for the emails and the concern. I really appreciate it. But you know what? Until next week, have a good week and what's left of your weekend. Thanks, fellas. Signing off. Bye.